AS1 में लॉगिन करना पासवर्ड सेम
मैम ना उस दिन कहंदे मैं ਤੁਹਾਨੂੰ ਦੱਸਾਂਗੀ मैम ने दस्या नहीं
पासवर्ड सेम ही है बस AS2 की जगह AS1 कर देना
कोई चक्कर नहीं
ठीक है क्योंकि ये सिस्टम AS1 है ना AS2 पीछे चल रहा होता है फिर
मैं मैम ਨੂੰ रजनी मैम ਨੂੰ ਆਂਦੇ ਪਹਿਲਾਂ ਇਹੀ ਗੱਲ ਪੁੱਛੀ ਤੇ ਮੈਮ ਕਹਿੰਦੇ मैं अपने पर्सनल तो लॉगिन करना है मैं ही कहूं कि AS2 तो नहीं चलाना
अच्छा वो एक्चुअली समझ बैठे कि ਜਿਹੜਾ ਸਾਈਬਰੋਮ ਤੇ ਲੌਗਿਨ ਹੁੰਦਾ ਹੈ
ਉਹ ਨਹੀਂ
ਉਹ ਸਾਈਬਰੋਮ ਤੇ
ਸਾਡੇ ਐਨੀ ਹੋ ਚਲੋ ਹੁਣ ਮੇਰੀ ਕਲਾਸ ਚ ਟਾਕ ਲੈ
ਕਰੋ
Good morning, students. Can you hear me?
Yes, ma'am.
Okay, good. We'll be starting today's topic in 1 to 2 minutes as students are joining. So in the last lecture we studied UML and the various diagrams of UML. And in the last lecture, I told you that what is the difference between function-oriented design and object-oriented design. And with that, I told you that how we can create a draft, a blueprint of a project. A blueprint of a project can only be created using these types of design tools like UML, Unified Modeling Language, diagrams, or we can say using DFD, structure charts, flow charts, data dictionary, and all these things. Now moving ahead towards the next phase, that is related to coding and user interface design. Now we'll discuss today. Whenever we are ready with our design, that is detailed design. I told you what is the difference between abstract design and a detailed design. Whenever we are ready with detailed design, the next phase of the particular our project from the paper to some form in the programming language that is called basically a jump from a simple-based to software conversion. It's called as user interface design. What is user interface design? How we can create a good user interface design? What are the advantages of creating a good user interface design? We'll study all these things, the components, advantages, disadvantages, the way we can create, and the metaphors that we can use in the creation of the user interface design. Apart from the study of user interface design, or we can say the detailed description of this user interface design, we'll also discuss code reviews. So we did, we know we do coding, but how we can review the code will be discussed in the code review. And after code review, if time permit, we'll discuss about software project management, how we can do project management, how we can do project scheduling, and what are the various steps for project scheduling, and how we can calculate the critical path. On all these concepts related to the scheduling will be discussed under the heading called software project management. So starting with first topic, that is user interface design. So this user interface design topic consists of interface design models, design principles, the UI characteristics, and user guidance, usability testing, and some of the examples. These are the contents of our this topic. First of all, interface design model. The UI, user interface design process. This process is an iterative process. It involves a close liaison between the user and the designer. Whenever you are creating anything, any user interface, therefore there should be an interaction, close liaison between the user and the designer. That is the concept. The three core activities that are there in this process are user analysis, system prototyping, and interface evaluation. From the user analysis, we mean understanding what the user will do with the system. System prototyping, develop a series of prototypes for experiments, and interface evaluation means experimenting these prototypes with the user, that this is the prototype, I have created a user interface prototype, whether you are satisfied. If user permit that he is satisfied, we can proceed, otherwise we'll move to backward and correct the errors related to the user interface. That is a main thing. So in case of UI design or user interface design, this is a we can say a very much important step in the software project management or in the software development, because the user interface is not attractive and easily understandable. You may be developing a very good project, but if it does not attract the user, it is of no use. So keeping things simple and easy, or we can say using metaphors, we can have a very good user interface design. So always remember, this is an iterative process, because if a user feels like this design is not according to what he needs, he or she or any company can tell the developer that I don't like this kind of design, and so that the company or the organization or the project manager can change the design as per the user requirement, because every stakeholder in the project development is important, and from the every stakeholder we mean that user must be satisfied. User means the person who is going to use that very particular software, or we can say the customer who is developing that particular software from any company or from any organization. So the three core activities, as I discussed, user analysis, understanding what the user will do with the system. If I am the user, I'll see what I'm going to do with this Zoom application. So this Zoom software is designed as per the requirement of the user. User means the teacher as well as the student. So it will cater to the needs of student as well as teacher. So user for the user will going to use that particular software should be the user analysis. Apart from that, system prototyping. From system prototyping, we mean developing a series of prototype for experiment. This Zoom application is not developed in a single day. It may be possible that for developing such kind of software, they may have tested so many prototypes for developing this Zoom application. Interface evaluation, experimenting with these prototypes with the user, providing prototypes to the user and testing whether it is working according to as per the user requirement. That is also the concern. The design process. This design process involves the user interface design process. Always remember one thing: we are designing in the form of paper form, and that is also a design, or we can say detailed design. But converting that design into some programming language, uh, into some GUI, graphical user interface, is this is explained in this diagram in this PPT. First is, you can see here, this is analyze and understand user activities. After analyzing, produce paper-based design prototype. From the paper-based design prototype, we mean the models. There may be a DFD, there may be UML. This defines a paper-based model. After that, evaluate design with the end user. This paper-based model is being evaluated with the end user. If the end user feel that there should be some kind of change in the paper-based thing, there is a feedback loop to this. Otherwise, from the paper-based model, what you can do is you can design the prototype. After designing the prototype, next is you will move towards the dynamic design prototype. After designing the dynamic design prototype, you are to evaluate your prototype from the end user, because I am the user, we are the user who are going to use particular kind of software. So it should be evaluated from the end user. That is the concern. After evaluating, executable prototype is created, and it is then again evaluated by the end user. And if it feels like the end user is not satisfied, the end user can give a feedback to change that dynamic design prototype. After the end user is satisfied, we develop the executable prototype and implement final user interface. So these are the steps. If you are not able to understand, if you are not getting what I have explained in this slide, you can raise hand. I'll explain it again. Is that clear to everybody? This is the design process of graphical user interface. Graphical user interface. This is a design process of graphical user interface. Analyze and understand. I'm repeating. Analyze and understand user activities. Produce paper-based design prototype. After paper-based design prototype, evaluate design with end user. While evaluating design with the end user, there may be possibility that the end user feels that there may be, we can inculcate some of the changes. After inculcating those changes, again a new paper-based design is formed, or we can say paper-based design prototype is formed. After that, we design that prototype. Designing a particular prototype and converting into a dynamic design prototype is the concern. Producing a dynamic design prototype, again evaluating from the end user. If the end user feels like this prototype is good, he can suggest for executable prototype. But if after evaluating, it feels that there should be some changes we can introduce, so this step can be repeated. So after that, we will be having executable prototype. From this executable prototype, we can implement final user interface. This is the of designing user interface. Now next is interface design models. There are 4 different models that occur in HCI design. These are the design model, the user model. The user model is in the perception of the system, and the system image. The 4 different models, like design model that expresses the software design, like we are explaining on the paper, like DFD, UML. The user model that describes the profile of the end user who are going to use the system. There may be users that are no voice users. No-wise user are those users who are not efficient in using the particular kind of software or system. They may be given system, but they are able to use that system simply by clicking on some of the options that are called no-wise user. They don't have any knowledge about related to the software or the computer, but even then they can access the computer. They are called no-wise user. Expert, we know what are the expert user. So we can, from the user model, we mean keeping in mind the profile of the end user. They may be cultural background, they may be experts, no-wise users. Next year, user model is the end user perception of the system. Like if I am using this application, this software Zoom, so it is the person or the developer must think from my perception how the person is going to use that very system. He will not develop the system from his perception, he will develop the system from the user perception, how he or she or any organization is going to use that very system, or students will be going to use a particular Zoom application, or teachers are going to use a particular Zoom application, or corporates are going to use this application or this software. The system image is external manifestation of the system. So the system image includes who look and feel and documentation. So that is the thing, how the system is going to look and what will be the documentation of using a particular kind of software is comes under the heading of system image. So that is a 4 different models that occur in the HCI design. UI models. in the diagram here, in this slide here, you can see the basically from the implementation model, we are shifting towards a mental model. So UI model is a, we can say, a mix of implementation model to a mental model, or shifting of mapping of implementation model to mental model. That is a concern. If that is totally on the implementation model side, it will not work. But if it is totally on the mental model side, it will work. That because it is a mental perception, or the person is going to use that particular software, or developer must think from the perception of the user. Design principles. Now, while designing any user interface, what should be the design principles? They include user familiarity, consistency, minimal surprise, feedback, memory load, efficiency, recoverability, user guidance. So the user familiarity. The first principle while designing any user interface includes user familiarity. Use terms and concepts familiar to the user. From the term and concept familiar to the user means the terminology to develop a particular software, the names of a particular kind of menu should be such that it should be familiar with the user. Like we use cut, copy, paste, but we cannot keep these and any other name for cut, copy, or paste. We cannot name paste something else. So from the paste, everybody knows that we have to paste particular kind of content from one area to another area in the window or in the Word document. So familiar name should be used while designing any user interface. Consistency. Comparable operations should be activated in the same way. Like if you feel like these are the comparable operation, so they should be implemented in the same way. Commands and menus should have same format. There should not be different format for commands and menus, or for a particular menu there should be different format, and for a particular menu there should be different. There should be consistency in total all the formats for menus, and there should be total consistency for all the commands in the menus. Like we use control B, control I, control U. From control we use everything with the control to highlight that particular text. So there should be some kind of consistency. Next is minimal surprise. If a command operates in a known way, the user should be able to predict the operation of the comparable command. So there should be like, there should not be like that user feel like this is a surprise that it works like this way, this command works like this way. It should be understandable, easily understandable to the user. If a command operates in a known way, the user should be able to predict. If the user don't know, user can try that it may work like this, I think so, that will be the. There should be a little surprise for, or minimal surprise for using a particular kind of command in the that particular window. If I know that control B works for bold, I can easily feel like if I want to do some kind of italics, it should work like control I. And if I do I want to do underline, I want to underline some text, it should work like control U. So that will be a, we can say, come with a minimal surprise, because everything will work related to the text in the Word document, in the PowerPoint, or any kind of document in the form of control P, control I, control U. So this kind of approach should be followed while designing the user interface. Next is the feedback. Provide the user with visual and auditory feedback, maintaining the two-way communication. So there should be visual and auditory feedback for user, that user can understand how the things are going to work in the user interface. Next is memory load. Reduce the amount of information that must be remembered between the actions. Reduce the amount of information that must be remembered between the actions. Minimize the memory load. So you can, from memory load, we mean that everything should be in the user interface while used by the user should not be remembered every time in our mind. The memory load should be minimal. Minimize the memory load by the user. User need not to remember everything related to the software. If I have to remember that this UM application, I need to remember all the keys or the operations, like all the shortcut names, it will be difficult for me to remember, because it will increase my memory load. It should be such that the memory load for the particular for using this application for the user should be minimal. User should not remember anything, but whenever he want to use that particular software, it will be easy for him or her to use that particular software. That is a concern. Next is the efficiency. Seek efficiency in dialogue, motion, and thought. Minimize keystrokes and mouse movements. So, while designing user interface, things should be efficient and simple and thoughtful. That means it should have minimum keystrokes and mouse movement. There should not be mouse very very much mouse movements or keystroke for doing a particular kind of operation. There should be simple things for um, increasing the efficiency of particular kind of software or user interface. Next is the recoverability. Allow user to recover from their errors. Whenever I am using any application or you are using an application, the user interface, it should be that we are able to recover from the errors. Include undo facilities, confirmation of destructive actions, soft deletes, etc. should be there. So whenever I feel like if I am going to delete anything from here, I cannot recover. There should be a soft delete kind of things or undo kind of things. If a wrong happen, we can recover our information in that particular in that particular software while designing the user interface. Next is user guidance. Incorporates some of the context sensitive user guidance and assistance. So there should be user guidance and assistant at every level, in every command, in every menu. Suppose I am not able to use a particular menu, I don't know what is the use of that very menu. There should be some context sensitive user guidance and assistance for every menu or every command, so that if I am not familiar with that command, I can use help to understand your user guidance to understand what this command means, what it is going to do. That should be there in the user interface. Now, next is characteristics. Is there any problem uh, in the class? Can you hear me? Everybody in the class?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Next topic we are starting is GUI characteristics. Next is GUI characteristics. So the characteristics of a graphical user interface includes windows, icons, menus, pointings, graphics, etc. And what does these mean? So from the windows, we mean like multiple windows allow different information to be displayed simultaneously on the user screen. This is one of the character we can incorporate while designing our user interface, that multiple windows can be opened simultaneously for various operations on the user screen. Next is icons. Usually icon represents a file including folders and applications, but they may also stand for processes like print driver. So icon should be such that they, from the icon we can understand the operations we can do with those icons. Next is menus. Menus bundle and organize commands. We know in the menu there are sub menus. From the sub menu we have further sub menus, and they bundle a lot of commands in themselves. So this eliminate the need for any command language. You need not to write any command of your own. Just because pressing on a particular menu list, and you can select and do the operation. So menu defines a number of organized commands. Next is pointing. A pointing device such as mouse is used for command choices from a menu or indicating items of interest in a window. We know what is pointing. Next is graphics. Graphic elements can be commands on the same display. So from the graphical representation, we can see what does those graphical representation will invoke which kind of commands on the same display. Next is advantages of GUIs, graphical user advantages. They are easy to learn and use. User without experience can learn to use the system quickly. The user may switch attention between task and application. In the case of graphical user interface, fast full screen interaction is possible with immediate access to the entire screen, because you can see the screen. A fast and full screen interaction with the user and screen is possible in the graphical user interface, and easy to learn, because from the interface you can easily see what does that particular item mean, what operations you can do, and you can easily remember that graphical interface in your mind rather than the textual command you type from the keyboard. So next, moving towards the problems in GUI. A GUI is not automatically a good interface, because many software systems are never used due to poor GUI design. So there are software systems in the industry that were designed, but they were never used just because they lack very poor design. They have very poor, no, not lack. They have a very poor UI design. So if you are designing something and the user feels that this design is poor, you should stop at that level and try to develop a design that is user friendly or user acceptable. Because if you are not able to design the things that are user friendly or user acceptable, though you are designing a very good thing, but if it does not attract the user is not going to use that particular thing. So while designing any kind of software, there should be good UI design. Next is, a poorly designed UI can cause a user to make catastrophic errors. So whenever we are designing anything, uh, or poorly designed UI can cause a user to make a catastrophic errors in those things. Now nobody asked me what is, ma'am, this catastrophic errors. But you know what is catastrophic errors? A catastrophic errors are those errors which when occur can cause damage to your software, to the particular application that you are using. So if you have designed anything very poorly, and user is using that very thing, and user is not able to understand what does that particular menu or a command mean, or after clicking on that particular thing, it will lead to some catastrophic errors, damage to the software. So poorly designed UI can result into a damage of the software just because user is not aware of those things. That is the meaning here, from the catastrophic errors, a sudden damage to a particular thing or a particular software. Next is user interface design, direct manipulation. What are the advantages of direct manipulation? User feel in control, are less likely to be intimidated by the system. Feel in controls cannot be intimidated by the system. User learning time is relatively short, so user can only learn using the UI. User get immediate feedback on their actions. Like if you are clicking on something, you will get immediate feedback whether it is according to working according to you or not. This is the advantage of direct manipulation. Mistakes can be quickly detected and corrected. Problems with the direct manipulation: finding the right user metaphor may be difficult. It can be hard to navigate efficiently in large information space. This will be a problem. Finding the right user metaphor. What does metaphor mean? I told you earlier, like we are using the terms like cut, copy, paste, and there are many such terms. That from the metaphor we mean a particular word from which we can understand what does this this particular word is going to do, what kind of operation this particular word is going to do. On clicking on cut, we know that it will cut that very text which we have selected. So that is a metaphor. Copy is a metaphor. Such things, paste is a metaphor. Save as, the difference between save and save as is also a metaphor. Save and save, all these things are metaphors. It can be hard to navigate efficiently large information space. So the direct manipulation will cause a problem that it will be hard to navigate efficiently in a large space, information space. It can be complex to program and demanding to execute. The complexity may increase with the direct manipulation of the GUI. Next is menu systems. Advantages of menu system. We know what are menu system. From the menu system, we mean we have seen Windows, we have seen many software, we have seen Word, PowerPoint, Excel, and we are very comfortable with those things. Why we are comfortable? If nobody has taught us related this Word or Microsoft PowerPoint or this Windows desktop, but even then we can easily do the things just because that interface is good user interface. This word interface is good GUI design. So menu system, the menu system is very simple and easy to understand in case of Word, PowerPoint, Excel, etc. The advantages of menu system rather than the command system. User don't need to remember command names. If we have menus like search engines, you can see on the screen references, literature, shopping, movies, TV, gardening, and many things like that. In the search engine, it is displaying all the search engines. So remembering all the search engines is very difficult. Remembering all the search engines is very difficult. So that should be kept in mind that a menu system is good just because we need not to remember every command. Because for you can see for the search engine there may be a lot of commands, like we have to press like Control G for Google Chrome, Sparrow ke liye Control K, Control A, Control H, Control Y or something like that. We need to remember, we need to type the whole command. But that is not possible in case of menu system. Only selecting the thing and using is simple in case of the menu system. Other advantage of menu system is typing effort is minimal. So user errors are trapped by the interface. Context dependent help can be provided based on the current menu selection. Easily context dependent help can be provided based on the menu selecting what you have selected. You can get that very help from the context dependent help section. Problems with the menu system. Actions involving logical conjunction. If we want to do particular two kind of conjunction, that will not be possible with the we can say this menu system. Because if I'm going to do bold, italic, and underline, I cannot do the three things together. I have to press bold first, only italic again, then use it underline again. So this kind of a conjunction of operations cannot be possible using the menu system. If there are many choices, some menu structuring facility must be used. So if there are many choices for a particular menu, there should be some kind of structuring facility available for using those things. Next is experienced user find menus slower than command language. There are people who feel like the menus are taking long than the typing the command, because though they know all the commands and they are very much familiar with the command languages. So finding menu is difficult for such people. Next is menu structuring. If you are going to design a particular menu or any menu, there should be menu. That concept is called menu structuring. So we have different types of menus like scrolling menus, hierarchical menus, selecting a menu, mapping menus, etc. Kindly answer these questions. I'm sharing one poll here. The three core activities of UI are user analysis, system prototyping, interface evaluation, whether it is true or false. Next is there is mapping of implementation model to mental model in UI design. Is it true or false? Gursevak Singh has raised his hand. Gursevak, is there any issue? You can type on the chat box or you can WhatsApp me, whatever you want to say.
मैम पोल शो नहीं हो रहा.
Okay, I'll see why it is. Gursevak, I feel like there is some network issue on your side. That is why you are not able to see the poll. Kindly answer these questions. I am ending this poll in 15 seconds. All are required to answer these questions. Ending poll, 10 seconds left. So answer to these questions is attend the three core activities of UI are user analysis, system prototyping, and interface evaluation. This is true. There is mapping of implementation model to mental model in UI design. This is also true. So moving ahead in the case of menu structuring, we know that there are different types of menu, and while structuring menu, what we can do, what we should not do, and what are those menus, and what are their names. Like first menu is scrolling menu. We know what is a scrolling menu. From the scrolling menu, we mean the menu which has a scroll bar, horizontal or vertical scroll bar. So this is a menu, and these are the menus. This way we have a menu. From the scrolling menu, we mean where there is a scroll bar right here. This kind of menu. Start scrolling menu. We can select the thing according to the scroll bar. This is our scrolling menu. Next is hierarchical menu. Hierarchical menu in which we can have hierarchies. Like we can move from 1 to 2 to 3 in this way. Selecting this, selecting from these and moving to the next menu. There is another menu, and from that we can select another menu. So hierarchically, there is that hierarchical menu. Selecting a menu item causing the menu to be replaced by sub-menu. Walking menu. A menu selection can cause another menu to be revealed. Selecting a menu, further menu can be selected. Associated control panels. When a menu item is selected, a control panel pops up with further option that is called associated control panels. So we know what are scrolling menus. Menu can be scrolled to reveal additional choices, not practical if there is very large number of choices. If there are 2 choices, we cannot use the scroll menu. But if we have lot of choices, like we are generally selecting, whenever we are selecting country, finding India, we have you must have seen that the menu used is the scrolling menu. You can scroll and find your country, because just because there are a number of countries in the world. So in that case, we can use this scrolling menu. Not practical if there is not a very large number of choices. Hierarchical menus, we know, walking menus, associated control panels. Next is command interface. We have discussed about the graphical user interface, and we know that in the graphical interface, we have studied the characteristics, features, and moving ahead with the command language. We can have a menu system or command interfaces. With the command language, the user type command to give instruction to the system with the command language, and it may be implemented using cheap terminals, easy to process using compiler techniques, and commands of arbitrary complexity can be created by command combination. So we can use these cheap terminals for typing some commands, or easy to process compilers can be used, or commands for arbitrary complexity can be created by command combination, like control A plus T plus 5 plus 7 plus. We can create a command combination, but they are of no use, I feel like, because people cannot remember such kind of command. Concise interfaces requiring minimal typing can be created. There can be a concise interface that can require a minimal kind of typing can be created. Advantages of command interfaces. It allow experienced user to interact quickly with the system, with the command interfaces, and command can be scripted. They can be scripted. Problems. User have to learn and remember command language. As I already told you that it will be a burden on the user to need to remember the command for doing a particular kind of operation for this for a particular kind of software. Imagine you are clicking on the things and using this Zoom application, but if you are told to remember all those commands for using this Zoom application, it will not be an attractive option for using for doing online classes, just because we need to remember a command for doing any kind of operation. Next is not suitable for occasional or inexperienced user. So it, as you are inexperienced or occasional user for particular kind of software or application, it will not be suitable for you. An error detection and recovery system is required. If an error comes, there should be an error detection and recovery system in case you are typing commands for doing operation. And next, last is problem is typing ability is required. If you are very much into command interfaces, you should have a very good typing ability. Now, next is analog versus digital presentation. So, digital presentation are compact, we know, takes up little screen space. Precise values can be communicated. While in analog presentation, easier to get at a glance impression of value, possible to show relative values, and easier to see exceptional data values that is not possible in case of digital presentations. Color use guidelines. So we have designed a graphical user interface. So while designing a graphical user interface, we need to remember the color combination or color use guidelines. For using particular color or some color or any kind of color for your menu design, for your user interface design, these things you need to remember. Color can help the user understand the complex information structure. Do not use only color to communicate meaning. For communicating any kind of meaning to a particular operation, do not use color, only color. You can use text also, highlight the text. Open, because it will lead to misinterpretation, because there may be people who have a color blindness or cultural differences. Design for monochrome, then add color. You can design the monochrome options like black and white options for GUI design. Use color coding to support user tasks. Use a color coding combination to support user task. Highlight exceptional events. If an exceptional event occur while doing some command operation or menu operation, uh, highlighted colors can be used, or allow user to control color coding. So user can use color coding according to their choices. Use color change to show status change. Suppose must have seen, if you have used undo and if you are again using undo, the color is changed, or it is not, we are not able to click that particular option just because status of that particular command, that particular operation has changed. That is a thing here. Don't use too many colors in your user interface. Don't use too many colors because it will create a confusion. Avoid color pairings. You may see in this which clash, here which clash is written. Such kind of color pairing should be avoided in interface design. Use color coding consistently. So the color coding should be consistent. It should not be like that. Like that, in case of bold, in Word, I am using black color for bold. In PowerPoint, Microsoft PowerPoint, I am using red color for bold. In case of Excel, I am using green color for bold. There should be some kind of consistency while doing color coding for a particular kind of operation. User guidance. The user guidance system is integrated with the user. It is basically a kind of help to introduce help user when they need information about the system or when they make some kind of error. It includes system messages. You must have seen that if something goes wrong, a system message is displayed on the screen, including error messages, documentation provided for user, and online help. There are some operations that are not, we are not aware of those operations, but at some point of time, we come across a particular problem and we feel that this problem cannot be solved, and we don't know the exact solution of a particular kind of problem. So we can have a option of documentation for seeing how we can do particular kind of operation, or there should be online help or some kind of system messaging. Like in Word, I'm using a particular kind of option in these days, like equation. How can I write an equation in the Word? There is a tool called equation tool that can be customized, that can be inserted in the Word. But most of us don't know how we can write equations using the equation toolbar. So there is a equation toolbar in case of Word. So such kind of things will you can only understand through online help or documentation provided for user. Help system use. It includes multiple entry points should be provided. If you are using any help system, multiple entry points should be provided. The user should be able to get help from different places. So there should be online help or user guidance manual or any person or any help center. The help system should be indicate where the user is positioned. Navigation and traversal facility must be provided in case of help system use. Error message guidelines, speak the user language. Error message should speak the user's language, give constructive advice for recovering from error, indicate negative consequences of the error. Like there may be message, if you open this file, this may harm your computer. These are the some kind of messages that are displayed while you are doing or do any kind of operation. Give an audible or visual cue. You can may insert audible or visual cue for a particular kind of error message. Do not make the user feel guilty. Error message should be like that. It should not make the user who are using the system feel guilty. If the user feel like guilty that their particular kind of error is invoked, user will not use your system in next time. That is a concern. It should not feel guilty. Usability testing. Observe a group of test subjects performing a predefined scenario. Which is test subjects, how many test subjects, which scenario, what to observe. So there should be a group of test subjects for defining a predefined scenario. User interface evaluation. So you have created a user interface. Now evaluation involves User interface design should be carried out, assess its usability. It should be evaluated for usability, whether it's able, we can easily use, how hard we can use, how soft we can use. We should categorize, or we can say on the scale of usability. Full scale evaluation is very expensive. We cannot evaluate everything in the user interface, uh, and impractical and not practical for some system. Ideally, an interface should be evaluated against a usability specification. A usability specification model is given, and you have to use or test according to that usability specification. However, it is rare for such specification to be produced. So that is not easy for specification to be produced. Next topic is, this was all about user interface design. Now moving ahead towards the next topic, that is code review. What is code review? And according to Wikipedia, what is code review? Code review is the systematic examination after designing this user interface, after doing coding. What comes is the code review. You can do code review only if you have created a code. So it is a, according to Wikipedia, it is a systematic examination of computer science source code. It is intended to find and fix mistakes overlooked in the initial development phase, improving both the overall quality of the software and the development team. So it involves making pieces of the source code available for other developers to review, with the intention of catching bugs and design errors before the code becomes part of the product. Suppose you are the coder and you have created a code. There may be possibility that there are number of error and there number of bugs in that code, but you are not, you will not be given a code for review. There are teams who review those codes that you have created for a particular kind of software. Before delivering that code to the end user, that code is being tested by the code reviewers. That is a thing, to just to find out the errors or bugs in that particular code. Code review methodology says think twice, code once. Whenever you are writing any code, you need to think twice and then write code. That should be the aim. You should not write the code before thinking or not thinking. That is because such kind of code will create a problem in the later stages. Why do we need code review? So we have created a code, or an expert feel like that I have created a code and my code does not require any kind of review. But that is not the only option, because every code in the company, in the organization is reviewed by the review team because of the following reasons. First is, mistakes are caught before they become part of the product. If you are not correcting mistakes, they may proceed further and will be a part of the product. So finding mistake and catching them on right time is a good practice, and it can only be done through the code review. Review code by second eye point. So from the second eye point, we mean reviewing code. Code review is not done by the developer. It is done by the other person. That is called the second eye points of the, to find out the mistakes made at the time of development and correction at that time itself. If I am not able to find error just because I have created a code, other person may find those errors. It reduces the bug reported by the testers and also the cost of testing. So before testing, you can do is code review. This code review is a phase that comes after the coding and before testing. So wasting effort, time, money on testing a particular kind of software, we can have a code review session. It ensures that codes follow standard defined by the organization. every organization have some coding guidelines or coding standards. And whenever code review policy or whenever code review is carried out, it is easily able to find out whether the particular developer has followed the standard guidelines and procedure set by the particular organization. If the team is geographically distributed, even then it is possible. Repetitive code blocks can be caught during the code review. If a particular repetitive code blocks have been used while designing, while coding, that can be easily recovered or caught during the code review process, and refactoring can be done based on that. Code reviews can often find and remove common vulnerabilities such as format strings, exploits, race conditions, memory leaks, buffer overflow, thereby improving the software security. If you are reviewing the code, you can easily find the things that may be vulnerable for security or any kind of other reason, like format string options, exploits, any race condition is there, or there is any memory leak operation, or buffer overflow. While reviewing your code as a reviewer, you can easily find these things in the software security. It acts as a knowledge sharing platform by fostering greater communication and providing the invaluable information. So whenever you are doing code review or your company is doing code review, it fosters the greater communication between the individuals and at the company, at the different company levels or at higher levels, and it will provide a valuable information to developer as well as to the reviewers as well as to the testers. Traditional code reviews. The idea of formal systematic code review generally considered uh, of a bunch of people sitting together around a table in a stuffy room, poring over dot matrix printer out of computer code together, red pens in hand until they were bleary eyed and brain dead. Earlier, traditional way of code review was that taking printout of the code and marking where there is an error in that code with the red pen was the approach that was used by the traditional code reviewers. The code review process. This code review process you can see in the diagram here involves coding. After doing coding, what you can do is you can request review. After requesting the review request accepted, right? Accepting, you can have code review. After coding is reviewed, you can write comments and suggest changes. Fill in review response form, and after writing comments and suggestion, you can again say that this coding is done. Again, if you feel like they request review, you can put the request review. If there is no request review, you can move towards review complete and check in code. This is a way the code review can be done in a process. What to check in the code? So whenever you are reviewing any kind of code that is created by some other developer, what you can see is flaws or potential flaws in that very code. What they have missed, but what according to you should be included. Consistency with the overall program design, because overall program design matters. So consistency should be there. The quality of code should be good while checking the code. So in this way, they can make write good or bad code, make a checklist of good or bad code. Like they can write bad where there is a bad way of writing the code, and they can write good where there is a good way of writing the particular code. These are some of the slides that represent how we can write good bad code while reviewing any kind of code in the organization. Like they have created classes, which classes are good or bad, they can be easily seen. So you can include commenting where there is no comment section, you can include comments or at those places in the code. Long functions, code block should be split into smaller functions. This is the best practice in the coding. Testing or debugging of a code that does a lot of things is difficult. Write each function so that it does one thing and only one thing. There should be code such that each function should define one operation. Hard coded value should be defined in constant or in config. This is an example of Pascal language. Error messages should be defined in central class. These are the examples of how we can see bad practice, good practice of writing a code. Try catch is used for exceptional handling and not for control flow. So you can use this try and catch for exceptional handling and not for control flow. But if you are using this for control flow, that will be a bad practice, and you can use this way for good code. This is writing a good methodology of code. You can mark there where there is a good or bad way of writing the code. Assembly version set according to version policy support quota. Unit test has been defined for the function. You must write where the code should be unit tested, where the code should be integrated tested in your code. Problems with the code review. The problem is on the both side, it feels that they have checked, like no need to double check this change list. If some problem remains, the reviewer will catch them. Here you can see the developer feels, this is the developer, he feels I have not to double check everything, because I feel like if I have done any mistake, that will be checked by the reviewer on the other side. On the other side, this red t-shirt reviewer will feel that no need to look at this change list too closely. Reviewer feel that I have not to see it very closely, just because I'm sure the author means the coder, knows what he is doing. So these are the problems with the code review. Now next topic is project management. Before that, we can have one poll here. Kindly answer these questions. Oh, you cannot answer. I'm ending this poll. This is related to the next topic. So project management. What is project? Any work with a fixed start and end date, temporary or temporary date basically. Anything that is temporary and having a start and end date and unique in nature is called project. You use this term called project in your common um, we can say in common way, like I've given a project by my teacher, this project is given by my friend, this project is given by my boss, because you have a fixed deadline for them. This is the start date, this is the end date, and you have to complete this thing on time, and that work is unique in itself, unique in nature. So this is called project. What is product? A product is anything that can be offered to a market to solve a problem or satisfy a want or need. It has a life. It has a life cycle with multiple stages. A product is conceived, developed, introduced, and managed in the market and retired when the need for it diminishes. So, a product is basically conceived, developed, introduced, and managed in the market and retired when the need for it diminishes. A product can only be developed within the context of a project. You cannot develop a product out of the context of the project, and multiple projects can occur within the product's life cycle. So though there may be more than one project in a while designing a particular kind of a product. What is project management? Project management is a methodical approach to planning and guiding project processes from start to finish. So a proper management of all the planning and guiding a particular project is called project management. It has, this management has a particular start and a finish date. What is software project life cycle? Software project life cycle is quite similar to the SDLC. Software project life cycle involve communication, requirement gathering, feasibility studies, system analysis, design, coding, testing, integration, implementation, operation, and maintenance. That is with the SDLC. Product life cycle involves conception of the product, growth of the product, maturity of the product, decline of the product, withdrawal of the product. And these things happen with the time. Like I have created a particular product, it is then growth is there, then the product comes with the maturity. After maturity, there is decline, and after decline, there is withdrawal of that particular product. What is the project management life cycle? Project management lifecycle involves initiation, planning, executing, monitoring, and controlling and closing. So, like software development lifecycle, there is a project management lifecycle. And project management lifecycle involves initiating any particular project, planning that particular project, executing, monitoring and controlling that project, and closing the project. Software project, whenever we are talking in terms of having anything having start or start and end date and is unique in nature, that is a generalized way we can say this is a project. But whenever we are talking about software project, a software project is a complete procedure of software development from requirement gathering to testing and maintenance carried out according to the execution methodology in a specified period of time to achieve intended software product. Need of software project management. Software is said to be an intangible product because we cannot touch that thing that software is, that is why software is called intangible. Software development is a kind of all the new stream in the world business, and there's very little experience of building software products. Most software products are tailor-made or to fit clients' requirement. The most important is that underlying technology changes and advances so frequently and rapidly that experience of one product may not be applied to the other one. All such business and environmental constraints bring risk in software development, and hence it is essential to manage software projects efficiently. So you can see here that this software revolve around three things, or we can say have triple constraints. The image above, the image on the right side shows triple constraints for software project. It is an essential part of software organization to deliver quality product, keeping the cost within the client's budget constraint and deliver the project as per the schedule. So schedule should be there, time constraint is there, cost constraint is there. There are several factors, both internal and external, which may impact this triple constraint triangle. Any of the three factors can severely impact the other two. Therefore, software project management is essential to incorporate user requirements along with the budget and time constraints. What are the duties of the software project manager, or what software project manager do? A software project manager is a person who undertakes the responsibility of executing software project. Software project manager is thoroughly aware of all the phases of SDLC that the software should go through, and project manager may never directly involve in producing the end product. He is not involved in producing the end product, but he controls and manages the activities involved in production. A project manager closely monitors all the various activities of development process, prepares and executes various plans, arrange necessary and adequate resources, and maintains communication among all the team members in order to address issues of cost, budget, time, quality, and customer satisfaction. So the responsibilities of project manager include related to the people, acting as a project leader, liaison with stakeholders, managing human resources. Human resources mean the employees. All the stake employees are in for a particular project are under this project manager. Setting up reporting hierarchy. From the reporting hierarchy, we mean like if the developer is developing something and he needs any kind of break or anything he wants to report to, from to whom he reports to is also set by the project manager. Managing project. Managing project involves defining and setting a project scope, managing project management activities, monitoring progress and performance of the project. That is the duty of the project manager. This analysis at various phases or at every phase is the duty of the manager. So if you feel like you are project manager, it is your responsibility to see the risk at every phase in the project development life cycle. So duty of the project manager is to manage everything from initiation to delivery of the product. Take necessary steps to avoid or come out of problems, act as project spokesperson. If anything he wants to convey to any organization or anyone, he should act as a project spokesperson. Now next is software project activities. Software project management comprises of a number of activities. Which contains planning of a project, deciding scope of software product, estimation of cost in various terms, scheduling of tasks and events, and resource management. Project management activities may include project planning, scope of project, that very thing that is called scope management, project estimation, estimating the size as well as cost of the particular project, project planning. Software project planning is task which is performed before the production or actual start of the software. So planning is done before the actual start, but it is there for the software production but involves no concrete activity and has any direct connection with the software production. So planning is not a very kind of, we can say, concrete activity, and it does not have any direct connection with the software production. Rather than it is a set of multiple processes which facilitates software production. Next is scope management. What is scope management? It defines the scope of project. This includes all the activities, processes need to be done in order to make a deliverable software product. Scope management is essential because it creates boundaries of the project by clearly defining what should be done in the project and what should not be done in the project. So it defines about it that this project is limited to these things. So that should be defined in the scope management. What is the scope of a particular thing? For it will cater to the needs of the user. So that defines a boundary, what need to be done and what need not to be done in that project. This makes project to contain limited and quantifiable tasks which can easily be documented, that can be written and can be noted down, and in turn avoid cost and time overrun. Because while designing any project, developing any project, there is a problem of cost and time overrun. So that can only be avoided if we have defined the scope management clearly, that this should be included and this should be avoided, and we have a clear boundary of our project, then we can avoid cost and time overrun. During the project scope management, it is necessary to define the scope, decide its verification and control, divide the project into various smaller parts for ease of management. Verify the scope. You need to verify the scope in the documentation. Control the scope by incorporate changes into the scope, by incorporating changes into the scope. Project estimation. For an effective management, accurate estimation of various needs is a must. With correct estimations, managers can manage and control the project more efficiently and effectively. There should be For estimating any kind of a project, there should be a clear measure or scale from where we can easily find the cost and time effort. With the correct estimation, managers can manage and control the project more efficiently and effectively. This can help in managing the project more efficiently and effectively. Project estimation may involve the following: software size estimation, effort estimation, and time estimation. Three things are there: size of the project, effort that is inculcated that is inserted in that particular project development, and the time we are sparing we are giving to that project. That is also the estimation we need to know before project is actually developed. So software size estimation. Software size may be estimated either in terms of KLOC. From the KLOC means 1,000 lines of code. If I am writing a single line of code, that is counted as one. If I write 2 lines, that is called, we say 2 lines of code, 2 LOC. If I write 3 lines of code, I'll call it as 3 LOC. If I write 1,000 lines of code, I'll write as KLOC. If I write 32,000 lines of code, I'll write it as 32 KLOC. So this is the terminology that is used in the software engineering. And from that, we can calculate the number of function point in the software. Line of code depend upon coding practices, and function point vary according to the user software requirement. So line of code depend on person to person, and on the coding practice they have used for developing the project. Next is effort estimation. The effort estimation means the how much effort you are putting, the employees, the human resources, everybody, every stakeholder that is involved in the project is putting the effort, is estimated before actual project development begins. The manager estimates effort in terms of personal requirement and man are required to produce the software. Personal requirement. From the personal requirement, the employees we require for developing a particular thing. So we measure this effort in the form of manner. How many number of persons, how many hours they have worked. That defines the effort. If a particular company has 100 employees and they work for 30 days, and for 30 days they work for 5 hours a day, so it will be 100 into 30 into 5, and this will define the effort in man hours. Such kind of things, how many number of persons, how many hours they are working, they will work. For effort estimation, software size should be known. This can either be derived by manager experience, organization, historical data, or software size can be converted into effort by using some standard formulas designed by the software engineers. Now, next is time estimation. Once you have estimated the size of the project, you can easily estimate the size of project using the this KLOC approach, as I told you, 1,000 lines of code, and effort is estimated. The next phase is time estimation. The time required to produce the software can be easily estimated if you are estimated the size and effort. Effort required is segregated into subcategories as per the requirement specification and interdependency of various components of software. Software tasks are divided into smaller tasks, activities, events, or work breakthrough structure, or we call it as work breakdown structure. If we have a particular kind of a software, or a problem, we can divide that particular problem into sub-problems, and those sub-problems can further be divided into sub-problems. This kind of structure for effort and time estimation is called WBS.
Excuse me, ma'am.
हाँ जी.
Ma'am,
This,
please change the
you are
marker.
not
It's
able
not
to see the screen.
Ma'am, the
Marker is
marker is so
okay.
light, it is not clear.
Okay, okay. I'll see. This is working. Now you can see problem.
Yes, ma'am.
Okay. This is subtask. This is subtask 2. I am writing here subtask sub T1, sub T2, sub T3, sub T4, subtask 4. So this can be further divided into subtask, task, subtask. In this way, we can divide the work into work breakdown structure, and this is called WBS. This can be created in various softwares available nowadays, and we can easily estimate the time. We'll study that in the open project. I'll send you videos or regarding this work breakdown structure. The tasks are scheduled one on day-to-day basis or in calendar months. There's some of the time required to complete all tasks in hours or days, the total time invested to complete the project. So that all that time that is required, sum of all the time, task times, like the task, the time taken by this task, this task, this task, this task, this, every kind of task is calculated and segregated, is combined or summed up to find a total time in hours or days that can be invested to complete the project. Remember one thing, this is the only the estimation of that very project. Next is cost estimation. This might be considered as the most difficult of all because it depends on more elements. Most elements of all because it depends on more elements than any of the previous ones. For estimating project cost, it is required to consider size of the software, software quality, hardware, additional software or tools, licenses, etc. Skilled personnel with task-specific skills, travel involved, communication, training, and support. So whenever you are estimating the cost, it should not involve only the size of the software. It should not consider only the lines of code. It should consider the quality of the code, the hardware, the tools, licenses required for particular software designing, skilled personals with task specific skills. There may be possibility that there is some computer engineer in your company and he is assigned some project, but he doesn't have an expertise on that very project. And he is given training related to the particular project. So that training cost should also be part of that very project to estimate the cost size, because training required by that person involves some kind of cost and that should be included in the cost estimation. And it travel involved for that training or understanding or doing any kind of meeting uh, uh, in the region or abroad should also be included. Any kind of communication should also be included part of the cost estimation. Any training and support, as I have discussed with you, should be part of the cost estimation. Next is project scheduling. This project scheduling in a project refers to a roadmap of all the activities to be done with specified order and within the time slot allotted for each activity. Project managers tend to define various tasks and project milestones and then arrange them, keeping various factors in mind. It is the duty of the project manager to define various tasks and project milestones. Milestones are something that some of the achievements that occur in the project. They are called milestones, and that milestones are set by the project managers, are defined by the project managers, and they arrange them keeping various factors in mind. They look for tasks and in find out the critical path in the schedule which are necessary to complete in specific manner and can strictly within the time allocated from the Critical path is a short, we can say the path that is a required to complete a particular project. Arrangement of tasks which lies out of the critical task are less likely to impact the overall schedule of the project. So the overall schedule of the project from start to the end defines a critical path that should be followed while you are developing or organization is developing any project. So project scheduling is very much important from the point of the view of the cost, effort, size, and delivery on, we can say, on time of a particular project. For scheduling a project, it is necessary to break down the project task into smaller manageable forms. Find out various tasks and correlate them. Break down the project into tasks, smaller or manageable forms. Find out various tasks and correlate them. Estimate time frame required for each task. Estimate a frame required for each task. Oh. Estimate the time frame required for each task. Divide time into work units. Assign adequate number of work units for each task. Like we have a task 1, task 2, task 3, task 2. And for every task 1, like assign adequate number of work units. Calculate the total time required for the project from start to finish. Number of days, number of months, number of people who will work for number of days or number of months. How to schedule or sequence activities. So this diagram, this part chart will explain you how can you schedule the activities. You can see here there is a start and end, and there are some activities here. From the diagram here you can see this is start, and from the start there is one activity that is further divided into two, and these activities will run in parallel. So they are on the parallel side, and these further activities will also run in parallel, and after that there will be a finish of the product on the project. Next process involves taking the activities and milestone and starting to sequence into how the work will be performed. You need to sequence all the activities. The result in the network diagram, this is the network diagram, also referred as project schedule network diagram. It looks like this. This is not a PERT chart. Network diagram shows just dependencies. So you can see there is a dependency. This activity cannot be done without these activities, and this activity, this blocks activity cannot be done without these activities, these three activities. So you can see if these activities are done, only then you can do these activities. So there is a network kind of link between the various activities. So that diagram is called network diagram. It represents logical relationships. If activity duration estimates are added, the network diagram could also show the critical path. If there is a duration defined here, 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 and here, this path will define the critical path. This path start here, 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 and will define the critical path. Number of hours specified in every activity. Methods to draw network diagram. In past, the precedence diagramming method, the arrow diagramming method, and the GERD method were commonly used to draw the network diagram. These three terms, precedence diagramming method, arrow diagramming method, and the GERD method, were used for network diagram drawing. Today, most network diagrams are created using precedence diagramming method. Types of dependencies in the network diagram or project schedule. The sequence of activities is determined based on the following dependencies. There are mandatory dependency, discretionary dependency, external dependency. First is mandatory dependency, or we can say the hard logic. Dependency is inherent in the nature of work being done or required by the contract. So that is, we can say, hard dependency. You cannot avoid that dependency. You must do this design before that design, or before that construct. So anything that can be, that need to be done before, is done before. So that is the mandatory dependency kind of example. Next is discretionary dependency. Discretionary dependency is that dependency that is preferred, preferential, or soft logic, that does not involve any kind of hard logic. So this dependency is determined by the project team. Discretionary dependency can be changed if needed, while other types of dependencies cannot be easily changed. Discretionary dependency are important when analyzing how to shorten or restrictions of the project to decrease the project duration. Or we can say fast track the project so we can avoid or prefer according to our choices. Next is external dependency. This dependency is based on the needs or desires of the party outside the project, like the government or the supplier. So that dependency is not in the hands of the developer. It depends on the project, government who is giving that project, or the supplier. Loads and lags in network diagram. In the network diagram, there are loads and lags. Loads and lags, not loads and lags, leads and lags. From the lead, we mean a lead may be added to start an activity before the predecessor activity is completed. For example, a coding might be able to start 5 days before the design is finished. So that is a lead activity. We can start coding before the design is completed. So that is a lead activity. A lag is inserted waiting time between the activities, such as needed to wait 3 days after pouring concrete before constructing the frame of the house. So the lag is waiting time that need to be inserted between the activities. Lead is you can do the things before a particular work is completed. That is called lead activity. Dipti Kumari, is there any issue? Next is, this is an example of network diagram. This means ES, EF, LS, LF. What does these mean? Here you can have an activity name, any activity, like I'm doing feasibility study, I'm designing anything. So that should be included here. Activity name, we can have feasibility here. Amount of float means the time we can have for that very thing, 5 days, 10 days. And this means earlier start, this means earlier finish, this means latest start, latest finish. From the earlier start, we mean how many days we can early start this activity, on how many days we can early finish this feasibility activity, and how many days or hours we can have latest start, and how many days or hours we can have latest finish. For every activity, we have 5 things: amount of float, early start, early finish, latest start, latest finish. Example network diagrams. You suppose you are the project manager for a new project, and you have figured out the following dependency. There are various activities like activity 1, activity 2, activity 3, activity 4. Is there any issue? So we have activity 1, activity 2, activity 3, activity 4, activity 5. So activity 1 can start immediately and has an estimated duration of 3 weeks. So we can have 3 weeks here. Activity 1, 3 weeks. Activity 2 can start after the activity 1 is completed and has an estimated duration of 3 weeks. So the activity 2 will have, here will have activity 2, and duration is, you can see 3 weeks, and it can only be started It can only be started while active 1 is completed. So here we can have activity 2 and here we can have activity 1. So activity 2 can only be started when activity 1 finishes. In this way it works. I will show you in the next diagram. Activity 3 can start after the activity 1 is completed and has an estimated duration of 6 weeks. Activity 4 can start after the activity 2 is completed, can have 8 weeks. So it will calculate what we can calculate from that. We can calculate a critical path, float of activity, float of any activity, 2, 3 or any, and total float of 2 paths that can, or longest float can also be calculated. So what is the duration of the critical path? They have calculated the duration of a critical path from these activities. The duration is the total duration of all the activities. What is the float of activity 3? You can see here that for the total floating of that activity is shown here is 5. What is the total float of activity 2? That is given by 0. Why it is given by as 2? Because total float is given by 2 just because it can start only after activity 1 is completed. The float is 2 here. But in case of activity, this activity, 3 activity, the float is 6. Just because 6 minus 1, it works like 4. So in this way, we can see how we can calculate the activity. So this is the diagram representing the various activities. Suppose this is the start and these are the activity A, D, E, F, G, B, H, C, O. This is the activity. 0 represent earliest start. This is the first activity. So and its duration is 4 days. So earliest start is 4. But you can early start. You can start from 0 because this is the first activity. You can earliest start is 0 and earliest finish is 4 because 4 days is required to complete that activity. So maximum finish day, minimum is 4. You cannot finish before 4. You cannot complete the activity in 3 days because the activity will take 4 days. So the early finish is 4. In the same way, latest start is 0 and the latest finish is 4. In this way, we can have activities. Here you can see the days required for complete this activity A is 3. It can early start is 0 just because it is a parallel activity. D and A can done parallel. So it early start is 0, earliest finish is 3. But latest start is 2 and latest finish is 5. So because if it will start at 2 after 2 days and it consume 3 days, so latest finish will be 2 plus 3, 5. So this is a 2 plus 3, 5 is here. In the same way, if the latest start here is 5 and it takes 8 days, then latest finish will be 30. If early start is 4 and duration is 8, early finish is 12. 4 plus 8, 12. If latest start, early start is 12, we cannot have early start 11 because it is finishing, only then it can be starting. So earliest start is maximum we can start after 12 days. We cannot start at the 10th day, 11th day. We can start only on the 12th day. If we are starting at the 12th day and it is taking 4 days, so the finish will be, earliest finish will be 16. But if the latest start is 22 days, we can extend that activity by the khatam ho jaye. If the earliest start is 22 and it is taking 4 days, then earlier finish will be 26. This is the way it works. So activity name, amount of float, and early start, early finish, latest start, latest finish. So you will ask me here, what is this amount of float means? Amount of float here is early finish, latest finish minus early finish. 4 minus 4, 0. 13 minus 13, 0. 17 minus 17, 0. 19 minus 19, 0. 26 minus 26, 0. 16 minus 20, 26 minus 16, 10. 13 minus 12, 1. 5 minus 3, 2. In this way, we can calculate the latest start, early finish of all the activities. But how this will be calculated, it will be given in the form of this way. A has the A activity does not have any preceding activity. Why? Because A activity is the first activity. But this B activity depends on A. A get completed only then B can move. So B can have preceding activity A and 3 weeks. C can have preceding activity A and 6 weeks. D can have preceding activity B and 8 weeks. E can have CD as preceding activities and 4 weeks. So this is the in this way we can draw the diagram for a particular activity. Before that, now we'll have one poll here. Answer these questions. Project cost estimation is done using lines of code, whether it is true or false. Next is in a project refers to roadmap of all the activities to be done with specified order and within the time slot allotted to each activity. Project scheduling is answer or project management. Whether it is it is called project scheduling or project management. Time is running. Kindly answer these questions. Project cost estimation is done using lines of code. Other one is dash in a project refers to roadmap of all activities to be done. Dash in the project refers to roadmap of all activities to be done with specified order and within time slot allotted for each activity. Abhinav, is there any issue?
Let's
So,
discuss the
project cost estimation is done using lines of code too, and dash in the project refers to roadmap of all activities to be done with specified order within the time slot allotted to each activity. So that answer is project scheduling. Project management is without time slot. Basically, we can manage the things without a particular time slot. But if we are scheduling the things that need to be done within a time slot, so answer is project scheduling here. You can see the answers, your response to these questions. Now next is, we were doing scheduling, and I told you that every activity, suppose there are 5 activities like A, B, C, D, E. From the diagram, it is very clear that A is the first activity because it doesn't have any preceding activity. From this table, we can see this B activity and this C activity is having A as predecessor activities, preceding activity. So this means that this B and C can run in parallel. This D activity has a preceding activity, and that activity is B. So after A, we move towards B, and from B, we move towards D. And this E has both C and D as preceding activity. So it can also be drawn using these activities. This E will have CD in parallel. This is a main thing. This is a duration. This duration means that this activity A will take 3 weeks. This will take 3 weeks. This will take 6 weeks. D will take 8 weeks, and E will take 4 weeks. For calculating paths and everything, we need to draw first the network diagram. After that, find out all the paths and critical paths. What is the duration of that critical path? What is the float of activity B and activity C? Here they have given an example that you need to calculate the float of activity B and activity C. So you can print this screen and can calculate the float for these activities using the network diagram, after drawing the network diagram. Then source working on activity 3 is replaced with another source who is less experienced. The activity will now take 10 weeks. So the activity 3 is now replaced with 10 weeks. If it is given 10 weeks, how it will affect the project? So that if it is given 10 weeks, it will affect the project. After some argument between the stakeholder, a new activity F is added to the project. There may be a case a new activity is added to a project. That means you have to change the network diagram. It will take 11 weeks, this F activity, to complete, and must be completed before activity E and C. So this F activity need to be completed before E and C. Management is concerned that adding the activity will add 11 weeks to the project. Another stakeholder argued that the time will be less than 11 weeks. Who is correct? So questions like these things can also come. If there is a duration issue, who is correct? You can also calculate this thing. Use the original information without a change to activity C listed in the original. So based on the information, how much longer it will, so the project will take, we need to calculate that. See, here you can see the calculating the critical path. These define the critical path and duration of activities. Start is, from the start we are moving towards 1, from 1 to 2, 2 to 4, 4 to 5, and end. You can see this dark arrow. This dark arrow represents the critical path. And there is another path called 1, 3, 5. And it does not involve all the activities, so this is not the critical path. Duration of these activities take 18 days. So the total length is 18 weeks just because it covers all the activities. This is the network diagram. And this is a detailed network diagram. You can see this one activity. this one number one activity has duration 3 days or 3 weeks. We are taking it as 3. So this is the first activity. So the early start is 0. Early start, this ES is 0. Earliest we can start from 0. अगर मैं अभी से शुरू करूं, I'll start the lecture from 10 and I'll consider it 0. And if I'm completing the lecture at 12, I'm considering it as 2 hours. So from 0 to 2 is the scale. In the same way, if this is the first activity, I'm taking it as early start as 0, and it is taking 3 days or 3 weeks. I'm just representing it as only a 3 numerics. So the early finish is 3 because एक एक्टिविटी को 3 दिन लग रहे हैं कंप्लीट होने में, तो 3 दिन से पहले थोड़ी खत्म हो जाएगी. तो अर्ली फिनिश क्या होगा, ज्यादा से ज्यादा 3 दिन में खत्म हो जाएगी. एंड what about the latest start? Late से late start क्या है, 0. Late start. And what will be the late finish? It is taking 3, so the late finish will be 3. So the float will be 3 minus 3, 0. Now moving towards the activity 2 and 3. This activity 2 cannot, this activity 2 will only start when activity 1 complete. Activity 1 complete after 3 hours, after 3 days, or after 3 weeks. So this will start at 3. If it completes at 3, it will start at 3. And it has a duration of 3. It has a duration of 3. Yeah, the 3 duration. So 3 plus 3, this 3 plus 3 will be 6. Early start is 3, early finish is 6. Early start is 3, latest start is 3, latest finish is 6 here. Next is the next activity. That is also dependent on the previous activity. So the early start in this case will be 6 and early finish will be 14. So just because 6 is the early start, 8 is the duration, total duration it will take. So early finish will be 14. The same way, early start for this fifth activity will be 14 and it will take 4 days. So early finish will be 14 plus 4, 18. So in this way, we can draw this critical path. But on the other hand side, you can see here, early start, latest finish is 3 and latest start of that activity is 8 here. Just because there is a time difference, because it will move from the back end. Are you getting what I'm saying? It will move from the back end. So this will be called as critical path for a particular kind of software project planning. Early start, you must know these terms. Early start, you must know these terms. Early finish, I will discuss 1 to 2 numerical related to this on the board in the next lecture. But before that, you need to understand what is early start and early finish. This is called early start. This is early finish. Why not this early start is 0 here? Because it will only start at 3 when one activity is completed. Activity 1 is completed. So early start is 3 and early finish is 6 here. Latest start is 3, latest finish is 6 here. After reaching here, you can see this is 18 and the float here is 0. It has 14 as latest start because 18 minus 18 is 0 and 14 minus 14 0. This will have, but this 14 will have 14 here. And what is the difference between these activities? 14 minus 9, 5. So this will form the foundation of this difference. 3 plus 5, that will form 8 here. So this will be the critical path and this will be the backend path, we can see. So this is the time estimation, that is 18 hours, 18 days or 18 weeks. This way we can calculate the early start, early finish for a particular kind of project schedule. Activity B, float 0. Activity C, this is related to the previous slide, this slide. So for this example, I'll give you these notes. And for this example, they have calculated the critical path. And the project, you can see here that if F is inserted, that will take, as I told by that, there is another activity that will take 11 weeks. Stakeholder who says the time will be less than 11 weeks is correct. New activity will be added to the non-critical path that has float of 5 weeks. Therefore, adding 11 weeks will make this path the new critical path. So the overall effect of adding 11 weeks will be a delay to the project for 6 weeks. The project will be delayed for 6 weeks. We'll discuss this problem in the next lecture on the board, and we'll give you more examples related to this just because it comes in your sessional as well as in your final paper. Ask you the interview also what is early start, early finish, latest start, latest finish, then project scheduling. This was all about today's lecture. If you have any questions or any queries related to, you can message me on WhatsApp. I am sharing this slide in your WhatsApp group as well as the video link. Thank you very much.